I want to do 11 and 12 first before we do 9. Let's do 11. So I've got a supply, 15 volts, R1,
You did it right though.
R2.
So far, every single one of them. I mean, I haven't been. The
10K.
longer you're on the hot streak, the higher the chances of
15K.
losing the streak. Really? What if I'm adding 1 plus 1? What if I'm adding 1 plus 1 and going That's not a streak. A streak? Yeah. That's a loop.
R3, 12K, R4, 18. So, calculate the voltages at the anode, calculate the voltage at the cathode, identify if the diode is forward biased or reverse biased. So, we want to find this voltage at A, and we want to, let's call this A and let's call this K. So, voltage at A. Hint. Let's read the hint. What does the hint say? Use the voltage divider rule. You're going to use the voltage divider rule over and over and over in electricity and in electronics. So, there it is. Voltage at A is NK over the total voltage multiplied by 15 volts, right? In a voltage divider rule, R2 over R1 plus R2 multiplied by supply voltage. How much? 10 over 25 times 15. What do you get? 6 volts. So the voltage here is 6 volts. Let's do the same voltage divider rule on the other side, at K. Voltage at K. 18K divided by 18K plus 12K times 15, right? How much? You see how the supply voltage is 50 and you've got a voltage divider? That's your voltage divider, right? 9 volts. So this is 9 volts. 6 volts on the anode side, 9 volts on the cathode side. Is the diode going to be forward biased or reverse biased? Question. Yes. Yes. All you have to do is be careful with the brackets in the denominator. No. Just the top. Because if you look at the voltage divider rule, VR2 over Vs is equal to R2 divided by R1 plus R2. Voltage divider rule says if this is Vs, this is R1, this is R2, then this voltage here is R2 divided by R1 plus R2, and that answer multiplied by Vs. That's the voltage divider. Okay, so 6 volts at the anode, 9 volts at the cathode. Is the diode forward biased or reverse biased? Reverse. Voltage at the anode, so let's write this down. Voltage at the anode is 6 volts. Voltage at the cathode is 9 volts. Voltage at the cathode is greater than voltage at the anode. Therefore, diode is reverse biased. which means that it acts like an open switch. Okay? So it's possible that a diode can have one voltage on the anode, another voltage at the cathode. It's going to determine whether it's going to be open or closed. So that brings us to number 12. Uninterruptible power supply circuit. Simplified version of it. So let's do this one. Everybody draw this. You see how it's all blank? Page 9 is all blank. So let's draw the uninterruptible power supply circuit in a block diagram form. What is an uninterruptible power supply? It is backup power. So think of lobbies, stairways, where you've got this box, so that in case of power failure, you've got some emergency lights that come on. Same thing with banks and big institutions, hospitals, where in case of power failure, you need backup power. You need a generator that kicks in, you've got battery power that kicks in, so that your computers still have power and they continue functioning. Okay? So that's called UPS systems. So, – 120 volts AC, 15 volts DC. Power supply. Plus, minus. That's the first part of my circuit. In the UPS system, I've got 120 volts coming in. It's converted to 15 volts DC. I've got a diode here, D1. This circuit is going to provide power to a computer. So there's no interruption of power. The 120 volts AC provides power to the computer system. First, it brings it down to 15 volts DC. Then what I have is this circuit here. Battery, 12 volts, backup. Diode D2. So, let's see how this is going to work. We're going to take two cases. Case one, normal operation. Case two, power loss. So case one, normal operation. I've got 120 volts AC, 15 volts DC, D1 forward bias. So D1 forward bias. If it's forward biased, the anode is 15, cathode is 14.3. Are you with me? With the cathode here at 14.3, that also happens to be the voltage at the cathode of D2. So imagine 14.3 volts present here, 12 volts present here. Is that diode going to be forward biased or reverse biased? Reverse biased. So D2 is reverse biased. So it's open. Reverse bias means open. So battery is standby. Batteries, this is open, this is an open switch, the battery is standby. It's not being used. Okay, why? Because D2 is open. 14.3 on the cathode side, 12 volts on the anode side. Just like over here. 9 volts on the cathode side, 6 volts on the anode side. Now let's say we've got power interruption. Now let's say power is lost. So let's say this is gone. If that power is lost for some reason, what happens to the voltage right here? That becomes 0, doesn't it? So anode D1 and voltage at the anode of D1 is 0. Okay? So therefore, with a voltage here of 0, okay, this diode is basically going to be open. Okay? Why? Because now D2 becomes forward biased. Okay? So D2 here becomes forward biased. It becomes a closed switch. 12 here. How much over here? 11.3 volts. So with 11.3 volts here and 0 volts here, that makes sure that the diode D1 is reverse biased, okay? D2 is forward biased. Reverse bias means that this guy is then open, this guy is now closed. What does it do? It provides backup power to your computer system. Okay, because of D1, now reverse biased open, battery is going to kick in and provide power to the computers, and the system is A-OK. So that's a simplified version of how UPS works. And the way that is because of this diode principle of anode and cathode. We'll come back and finish off number 9 next class, and then we'll move on to LEDs and Zener diodes.